Friends, here we are gathered for the Digital Electronic TA3 activity from SYB Tech, and outline about today's topic is introduction, problem statement, truth table, K-map for output, circuit diagram and conclusion. So introduction about the problem statement is design and implementation of the combination logical circuit. Means it is a circuit in which the output depend on the presence combination of input, and they are generally made up of the logical gates. The output of the each logic gate is determined by its function. So that multiply by 5 to an input decimal digit represent in BCD, and the output is also in the BCD. Show that the output cannot be obtained from the input line without using any logical gate. So another is BCD number system. BCD is also known as the binary coded decimal. It is a form of the binary encoding where each digit in a decimal system it represents in the form of bit. It is very fast and efficient system that convert the decimal system into the binary system as compared to the existing binary number. It commonly used for the displaying alphanumeric. It computing and the electronic circuit binary code decimal is a class theory, and also it usually for 4 or 8 byte. So it can be basically take advantage of that fact that any one of the digit numerical can be represented by the 4-digit pattern. So most of the obviously way of the encoding digit is natural BCD, where each digit is represented by the corresponding 4-digit binary value. Here we take an example of the BCD or binary code decimal of the 15 is 0001.
Hello, my name is Vaishnavi Sonone, roll number 98. So we have a given a problem statement that we have to give an input in BCD number and the output will become a 5 times of a input in BCD. So truth table for our problem statement is we are going to give a BCD input like 0, 1, 2. We know that BCD numbers are from 0 to 15. Here 0 to 9 are valid BCD and 10 to 15 are invalid BCDs. So uh, when 0 is multiplied by 5 it will become 0 0. When 1 is multiplied by 5 it will become 0 5. 2 is multiplied by 5 it will become 10, likewise up to the 15. So the input BCD in binary form like 0 0 0, 1 will become 0 0 1, 2 will become 0 0 1 0, likewise until the 15. And our BCD output will become, we can write our BCD in 4 bit also and 8 bit also. Here we will we will given our output in 8 bits. So BCD output in binary form like 0 0 0 0 0 for 0, for 5 like this, and up to the 15. So let's show how to form a K-maps for our truth table for forming a combinational logic circuit. So here at a place 0, 1, 3, 2, 4, 5, 7, the all entries are 0. So we are going to put here all the entries 0, 0, 0, 0, 0, 0, 0 in all the shells. So at the output or at the end of a K-map, the all entries are 0, hence I1, I5 and I7 will become 0. So next came up for I2. The entries here I2 1 entries are at 8 and 9 position. So we will put here in K-map at 8 and 9 1 1, and we form a grouping. From this grouping we will find out the equation that A B bar, and here a common is D bar, so sorry C bar, so it will become A B bar C bar. And here we can see that the entries in I2 are is same as entries in A here. So so ultimately I2 is equal to A. In next K-map we will construct the K-map for I3. So entries in I3 is 1 1 1 1 at 4, 5, 6, 7. So we will put the entries in 4, 5, 6, 7 shell, and the equation will become a bar b, likewise a bar b, and the we will see here entries of I3, that 1 1 1 1 1 is same as in input B 1 1 1 1 1. So this become I3 will become equal to B. Likewise KMAP for I4 also having the same entry as a C, that 1 1, like here this one and this one. So I4 is equal to C. And the next for IC and I6 and I8, I6 having entries like a D, and I8 also having entries like a D.
Also, there are some advantages of the BCD system are an advantage of binary code decimal system in each decimal digit is denoted by a group of four binary digits, and that is allow to easy conversion between a decimal base of 10 system and the binary a base of 2 system. And another is it is easy to encode and decode decimal into BCD and vice versa. Also, it is also simple to implement a hardware algorithm for the BCD converter, and it is very useful in digital system. Whatever decimal information is either input or display as output, such as digital voltmeter, frequency converter, and the digit clock all use BCD as they display output display information in decimal. Disadvantage that BCD code voltmeter, frequency convert, and digital clock all use BCD as they display output information in decimal. But the disadvantage like BCD code for a given decimal number require more bit than the state binary code, and hence there is difficulty that represent of the BCD form in high speed digital computer in arithmetic operation, especially when the size and capacity of the internal register are restricted are limited, or the operation use BCD code require a complex design of the ALU, that the strength binary number system or the speed of the arithmetic operation that can be realized using BCD code is naturally slow, due to which the complexity hardware circuit involved. And advantage of the BCD is it can be converted to a character form of or a display example to a text-based format such as XML, or to give string signal for a system segment display. It is a simple per digit mapping and can be done in linear or offline time. Converging for pure binary involve related complex logic that speed digit and far so larger number. No linear time conversion algorithm is also seen by using the binary number system and convert to any another form in the numerical system. Also, the Y is called the logic combination logic because it based on the basic logic such as NAND, NOR, or NOT gate that are combine or connected together to produce more complicated switch circuits. And the conclusion about the topic is BCD was commonly used for displaying alphanumeric in the past, but in the modern day BCD is still used with real-time clock or RTC chips to keep track of world clock time. And it's also become the one for embedded macroprocessor to including an RTC. It is commonly for RTC to store the time in the BCD format. Also, sometimes the special bit are used for the sign or